This lesson is on finding the least common multiple. The least common multiple of two numbers is the smallest number, not including 0 or 1, that is a multiple of both. The least common multiple of two numbers is always larger than either number. Well, first of all, we have to think about what a multiple is. A multiple is a number that when you multiply by 1, by 2, by 3, by 4, and so on. So here's examples of multiples of 3. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and so forth and so on. What we do is one way is to list the multiples and find the one that shows up in both of them first. Remember, it has to be a bigger number than what you started with. So the multiples of 3 and the multiples of 4 show us that 12 is the least common multiple. Let's practice this. The first thing we need to do is list the multiples. So here we have the multiples of 2. We start with 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. Now let's go back to the multiples of 4. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and these will continue on and on forever. But I don't have to keep going because I notice I have two numbers that match. In this case, I have the 4s and I have the 8s. But remember, we want the least common multiple. So that means we want the smallest that's in both of the numbers. And the least common multiple for this set is going to be 4. Go ahead and pause the video and try the next one. List the multiples of 6, list the multiples of 8, and then try to find the least common multiple. When you return, I'll give you the answer. So first we need to start with multiples of 6. 6 times 1 is 6, 6 times 2 is 12, 6 times 3, 18, 6 times 4, 24. I usually try to do 4 or 5 just to see. Now let's list the multiples of 8. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, but I notice I don't have to go any farther because I see I have 24 in both numbers. So the least common multiple of 6 and 8 is 24. Another way we could use it is using our prime factorization. This way is a little trickier, but I want you to see it, and it's used when you use very large numbers. Today we'll be using smaller numbers, just for the examples. First thing we need to make our factor tree. 12 can be broken down into 2 times 6. 2 is prime, so it comes down. 6 is not prime, so we bring it down as 2 times 3. 8 can be broken down into 2 times 4. Again, 2 is prime, so it comes down. 4 is not, so we break it down into 2 times 2. All of those numbers are prime. Now this is the difference between greatest common factor and least common multiple. We're going to actually use our exponents with our prime factorization. So for 12, I know I have 2 to the second power, because there's 2 2's, times 3. And for 8, I see I have 1, 2, 3 2's, so it's 2 to the third power. Now this is where it gets a little tricky. We want to take the base with the highest power. So looking at our example, 2 to the second power and 2 to the third power. Which one has the largest or highest power? In this case, you're right, 2 to the third power. So we're going to write that over here. Times, now you see that lonely 3 there. That really is 3 to the first power. And since it's the only 3, we need to include it also. So you can write it as 3 or 3 to the first power. Means that there's only one 3 there. So let's write this out and multiply. 1, 2, 3, that's 2 to the third power, times 3. So 2 times 2 is 4, and 4 times 2 is 8, and 8 times 3 is 24. So the least common multiple is 24. Go ahead and try the prime factorization for 15 and 20, put it into your notes, and we'll review this one when we get back at school. Good luck!